As for example, in this case, you can see we have got a cholesterol value of 10 patients. And you can see that these are the values, 200 and then 210, 145. So if you want to take the mean, it will be like sum of all divided by the 10. And this will be 186.6. Similarly, if you want to calculate mode, it is 220 because that is the most common occurring. And if you want to calculate the median, then definitely it will be like you have to take, because it is 10, so even number. So if you are going to do it manually, it will be like 180 plus 220, which is the central value, because you have to arrange the data here, which is not arranged here as a descending. Then in that case, these two values will be the mean of these two central value will be the median. But you don't have to calculate any of these values, and the JAMOVI, it gives the value when you click the data or when you click the option. Now, if the data is normally distributed, this mean, median, and mode, it coincide. Mean is the most sensitive measure of this data. Like we call it as a, like it doesn't get affected. It does get affected by the extreme values. That's why we call that it is a very sensitive measure. And both mean and median can be used in case of a normal distribution. In case of a skewed distribution, because mean is pulled up in the direction of the skew. So you can see here that mean, this value, it has been pulled up in the direction of the skew, because skew is always decided by its tail. So we can say that it is the right skew and mean is pulled up here. So in this case, it's better to use median, because then median will be a better way to express the central tendency. So in case of a skewed distribution, median is a preferred way to communicate about the central tendency, because mean is dragged in the direction of skew and median is not affected by the extreme values. So if I want to summarize all these measurement of central tendency, then I can say that for nominal data, we remember we have studied the 4 types of measurement levels yesterday. We studied about the nominal, then we did ordinal, and then interval, and then ratio. So nominal, when you change the order of the code, it does not matter, like male and female, like race, maybe black, white, and others. Similarly, if you if you are using a nominal data, then the best measure of central tendency is the mode. If you are using a ordinal data, then the best measurement will be the median. And if you are using an interval and ratio, which is not skewed, then mean should be used. And if this interval and ratio measurement, that is a skewed one, then we use median. So this we did about the central tendency. Now coming to the measurement of spread or variability. So this measurement of spread is measured by the range. So range is the highest minus lowest value. Then the other measurement of this spread or the variability. So we measure how much spread the data is around the central value, that is the mean or median. So the second one is the standard deviation or variance for a population. So when you square standard deviation, which is when you take the under root of variance, then it is the standard deviation. And then it can be for a population, and then the standard deviation and variance can be there for a sample. So remember we did about the population parameter and sample statistics yesterday. So which is known as the standard error in this case. So now coming to another example, how to calculate the variance. So variance, it is also known as the mean sum of square. So ultimately, how do we calculate it? We take the sum of square. So just for example, you can see here that this was the same data set 10 data, which we have seen in the earlier example. And the mean which we calculated, it was 186.6. So what I did, I just took out the difference of this individual value from the mean. So this minus this. So it will be like, if this value is bigger, then it will be as a positive sign. But if this value is smaller, then you can see this will be as a negative sign. So this you can see as a negative sign. But since we have to square this value, so this sign does not matter, because we just want to know regarding what is the distance from the mean. So you square it and then you add everything, because what we have done as a formula, you have to know the sum of square. So this is the square, its sum will be the sum of square. And if you divide it by the total sample size minus 1, it is the variance of the population, or variance of that sample. So here we can see this we have seen. So its value, the total sum will be 9542.4 and total sample size is 10. So 10 minus 1 will be 9. So the 1060 will be the value of variance. And I said that if you take a square of this variance, then it will be the standard deviation. So square of 1060 will be the 32 square root, not the square, I'm sorry, square root. Then standard error, if you know if you can recall your sessions, maybe previous sessions or your reading, then standard error, it is normally defined as sigma by under root n. Now, what is this sigma? So this sigma is the standard error of the sample. And this standard error, this sigma is the standard deviation of the sample, and this n is the sample size. So the standard error here will be the 32.56, what we have calculated from the previous calculation. And this under root n, because sample size is 10, so its under root will be your 3.16. So standard error is 10.30. So we have just shown you on a small data set how to calculate this manually. But again, this was only to make you understand what is happening in the background. Otherwise, in any software, you don't need to calculate any of these values, be it SPSS, JAMOVI, Stata, or any software. So now how to check for the normality of the data? Because on basis of normality, we write like what measure of central tendency we are going to use. So like if I have measured a blood pressure, maybe an SGOT level of 5%, and I want to decide whether I should use a mean or median to describe my data, what should I do? So like, see, here are the values. So the systolic blood pressure values are the 110, 108, 120, 122, and 100. And if I see the SGOT level, it is 10, 110, 8, 210, and 12. So you can see that there are outliers here. Like there is a value of 210 and then there is a value of 8. So in case of the first systolic blood pressure, the values are less dispersed, whereas in case of the SGOT, the values are more dispersed. So in that case, how should I use the criteria? What measure of central tendency I should use? So in the values in a continuous data can have a normal distribution or it can have a skewed distribution. So for normal distribution, you can use mean, standard deviation, and median also, and interquartile range, because mean and median, it will be very much near to each other. But for skewed, generally we use the median and interquartile range. So now how to decide for the normal distribution? So normal, what is a normal distribution? A normal distribution is like a distribution of the variable where most of the observation, they tend to cluster around the central peak. And then the probabilities, which are values which are further away from this, they get adjusted near both the two sides. So they taper off equally in both the direction. And that's how that bell-shaped curve, which we call, that is usually obtained. So many natural values like maybe height, weight, BP, IQ, that follows a normal distribution. And there are two ways to assess or judge this normal, whether the data is normally distributed or not. So there is an objective way for the measurement and there is a subjective way. So let's see how we can check for this normality. So the objective way or the numerical way is there are three basically measurement to check for normality. So it is sensitive for the low sample size. So if the sample size, we say that it is less than 50, then only this objective way is useful. Otherwise, if the sample size is more than 50 or if it is a large sample size, then generally you should use a subjective way of the measurement of normality. So the first is to measure the skewness. So if you are measuring skewness, that tells you regarding your normality. Then this kurtosis also, this also tells regarding the normality. And then there is a test which is known as the Shapiro-Wilk test, which tells you regarding the normality. We'll see each of these three one by one, but for right now, you should remember that these are the three ways which are the objective way, and seeing the value, you can say whether the data is normally distributed or not. But the essential criteria is that the sample size should be less than 50. Now coming to the subjective way. So subjective way is the basically the graphical method. So in this case, you need a lot of experience. Why? Because you have to see the plot. And if you have to interpret the plot, maybe if you have just started seeing the plot, you may get confused initially that what to say. Like for you, it may appear normal. For the other person, it may appear not normal. So there can be some inter-observer variability. But as you move ahead with your data analysis, then at certain point, you will have this confidence of gaining this experience that no, this is a normal distributed data. So it is applicable basically for sample size more than 50, and quantile plot, which is also known as the QQ plot, and histogram. These are the two methods which we use to see the normality if the data is more than 50. So coming to the distribution, so in this graph, what can you see? So we can see that there are two groups, and if we see the graph of both these two groups, males and females, then I can say that both are normally distributed. But if I see this, that one is normally distributed, another is not normally distributed, then I need to think what I will be doing. So coming to the another objective way, which is the Shapiro-Wilk test. So what is a Shapiro-Wilk test? A Shapiro-Wilk test is an objective way of testing the normality in which your null hypothesis states that the data is normally distributed. So remember that if the null hypothesis states that the data is normally distributed, then what is my desire? So I will always be, I am desiring that my null hypothesis, the value should be more than 0.05. That means this null hypothesis is accepted and the alternate hypothesis is rejected. So I always want my null hypothesis to be accepted. So for that, what is the criteria? That the p-value should be more than 0.05. So if the value of Shapiro-Wilk, p-value of the Shapiro-Wilk test is more than 0.05, then we can say that the data is normally distributed. So coming to the this p-value, so you should always look for this p-value. But again, we have discussed this earlier that it is most suitable for sample size less than 50. So this is again one a plot for height of 14-year-old girl, and you can see here that normally mean is 1.5 and standard deviation is 0.07. So it is also said that if the standard deviation is less than like maybe the 50% of the this mean, then it is normally distributed. You can see here that there are two graphs which is the normally distributed. Again, you can see this is regarding the variability. Both these, one has got high peak and the other is more variability is more. In this case, you can see the standard deviation. So the first, the blue one, it has got a less standard deviation, which is 15, whereas the second has got a more standard deviation, which is 30. So although both the graph is having a same mean, just by mean, you cannot say regarding the dispersion. So this is regarding the dispersion, which is more in case of the red dotted graph. So by graph also, you can have a idea regarding the central tendency and regarding the variability. So now coming to the skewness. So remember in the objective way, we dealt for three situations. There was one which was Shapiro-Wilk test, then the second one was the skewness, and third one was the kurtosis. So the skewness, it measures the symmetry of the curve. Remember, we discussed that right skew, left skew when we were doing the mean. So it measured the distribution and the symmetry, and it is measured by the direction of the tail. So you measure whether it is a right skew or the left skew. But again, if the value of that statistics, if it is less than 2, then we say it is normally distributed. It can be plus minus 2 depending on the right skew or left skew, but its value should be within plus minus 2. Then we can say that this is normally distributed. Now coming to the second measurement, that is the kurtosis. So kurtosis is for the peakedness of the curve, how tall the curve is. So it measures the peakedness of the curve. So if curve is very tall, we call it as a leptokurtic. If it is less peak, then we call it as a platykurtic. So leptokurtic is more peak and platykurtic is less peak. And like skewness, if its value should be within plus minus 2. So again, plus will come when there is a more peak and minus will come when there is a less peak. So this is just a graphical representation. You can see this is the positive skew, this is negative skew, this is the kurtosis positive value, this is the negative value. So now this was the objective way of assessment. Now coming to the subjective way of assessing the normality. So histogram is one way. We'll see how to draw that histogram, and then you can have that superimposed density plot also. And then there are QQ plot. So this quantile plot, it is the one of the best method for assessment of normality graphically. And if the data is normally distributed, then you will see that there are circular dots which will be arranged in that diagonal line. So a normal QQ plot appears like this. So you can see there are two variables on all the data points. So this is the expected normal and this is the observed value. So the dots will be distributed across this diagonal line. Similarly, in females also, you can see that this will be distributed along the diagonal line. So this is the normal QQ plot. And in this also, you can see like you can study the outliers also. So any data point which is measuring more than 1.5 box length than the from the edge of that box plot, that is known as the outlier. And in outlier, so in a box plot, this box plot is basically, you can see in a box plot, there is a box and there is a central line. So this central line represents the median. The lower one, it represents the first, that is the first quartile. The second Q3 line, this represents the 75th percentile. And this whole, width, this represents your interquartile range. Then there is a minimum point, which is the Q1 minus 1.5 times interquartile range. And then there is a max. But I can see myself. So the maximum, you can see that Q3 plus 1.5 times interquartile range. So any value which lies outside these two, maximum and minimum, we call it as an outlier. And then these blue line, this is known as the whisker. So many times it is known as the box and whisker plot. So this is the basic concepts of we can say. So right now I'll be showing you, I think we have seen this distribution, but we have not shown you the normality. So maybe I will show that and I will be explaining you the graphs also. So questions already, it has been typed here also. You can see frequency distribution table across or same or specifically also. I will be showing you. So let me see the questions. So the questions will be there in day 1 folder. So this is the question which I have to show. So a table 1, I have to draw the gender-wise distribution, age group-wise distribution of patients according to smoking and comorbidities. So for that, we have seen this yesterday also, but again, I'll show you the gender, age, smoking and comorbidity. So for that, I'll go to the exploration, descriptive. In descriptive, if I have to see, so gender, Then comorbidity wise, smoking. So if I see total number of comorbidity, that also, and then maybe smoker, whether the person is smoker or not smoker. So that smoking status, maybe probably this stroke is there. So that is not here, maybe this variable is not, I cannot see this. So this you can see, I have to, you have to click because this is a categorical variable. So uncheck this because you don't need mean median, and then click on the frequency table and it will give you the frequency table, maybe with the total number of comorbidity and males and females also. Similarly, if you want to show the, then the second question was across. So maybe if you want to show these variables, then you can split it, like maybe the, if you want to see like what is the diabetes status, and you want to see maybe any continuous this thing also descriptive, then you can write like maybe SBP if you want to see variable the mean. In that case, you need to check by the mean. So with that mean value, maybe median, that you can see. And the other question which was there, that was regarding, so this was the dummy table, which is there. So male, female, and then age group wise distribution. So all these tables are there, and you can get these tables from the JAMOVI itself. And you can write here also, like yesterday we discussed. So this was regarding your frequency table. This, in that case, you don't need it. So we will again go to the now. This continuous variable. So if you want the continuous variable, then you may put these variable like SBP, DBP, SBO2. You can click mean and median. If you want percentile, you can click 25th, 50th, and 75. And okay, so Saurabh is asking how to keep the variables in the rows instead of columns. So maybe here you can change it variable across row. You can see in descriptive there is an option. There's a drop down this menu. Can you see? Let me focus this one. So if you change this, if you want like row and column wise, you can use this option, and you can use the drop down menu. And then if you go down, you can click for the range. You can click for the interquartile range. If you want to see the skewness and kurtosis, like we have read Shapiro-Wilk, although the value of Shapiro-Wilk statistics, because the sample size is large here, probably it is 180. So Shapiro-Wilk not, it is not the ideal way, but still you can click and see the value. So you can see mean, like it is 26 in this case, median is also nearly same, and it is nearly same. So I guess like these will be normally distributed. You can see the interquartile range also. Range, then skewness. Skewness, the value is definitely less than 2 in all the 4 cases. And then kurtosis also, you can see the value is less than 4. Then this is the Shapiro-Wilk, W is the Shapiro-Wilk test statistics, and its P value you can see. So in 2, for SBP and DBP, it is in all the cases, it is less than 0.05. So that's what I said, that when the sample size becomes very large, this Shapiro-Wilk statistics will always be less than 0.05. And if we go by the value, then you will have to say that this is not normally distributed. But ideally, that's why I said that this Shapiro-Wilk statistics is not sensitive for the data where the sample size is more than 50. And these are the percentile values which you can see. So this is regarding the descriptive. Now I have to show you the graphs also. So graph and plot, you can see here that there are various options. So first I'll be dealing with this histogram and density plot, and then we'll see the box plot also, and then QQ plot. Maybe if simultaneously you want to see, because these you will be doing for the continuous data. So this histogram, if you click, you can see that for all these variables, the histogram will appear. And yesterday we discussed that if you want to change the view of the this graph, then you can go, it is default in nature right now. If you want to keep it minimal or any other this thing, then this appearance will be changed. And then again, you can, so this is the histogram of BMI score. This is for the systolic blood pressure. This is for the diastolic blood pressure. Similarly, if you want to have a density plot, so density plot is basically it overlaps it and it smoothen its edges. So this is the density plot. It gets superimposed. You can uncheck the histogram also. Then in that case, you will only be getting this density plot. And if you click both, then you will get the underlying histogram also along with that. And then you can see the box plot. So before we see the box plot, let's click the QQ plot. So if you click the QQ plot, this QQ plot is applicable for the large sample size. Remember, we discussed that for large sample size, QQ plot or quantile plot is the best way to measure the normality. So you can see here, this is the QQ plot of SBP. If I go up, this is the BMI score, this is the QQ plot. So you will see that majority of the data points that is distributed along its diagonal. So this is the way you have to say that this is normally distributed. In this case also, you can see that most of the data points are along this diagonal line. And if I go down here also, here you can see that there is some problem. This is not the way the above graphs were. And similarly, if you see the density plot also, it seems to be a bit skewed. Not. So you can say that the fourth variable was SP. This was SpO2. So you can say that SpO2 doesn't seem to be normally distributed, seeing the visual inspection of the QQ plot. So these are the tests for normality if the data is large. So Govind, I guess now you are clear regarding in large sample size how to check for normality. Are you okay with this explanation? You have to say something. Yes, no.
For a large sample size, we can do a Shapiro-Wilk test or not to do.
No. It is never recommended because it will always be, p-value will always be less than 0.05. Then you will say that that is not normally distributed, but that is not the actual case. So for large sample size, you should not go for Shapiro-Wilk. Ideally, you should go for the QQ plot.
QQ plot. Okay, ma'am. Thank you.
Okay. So this now coming to the box plot. So box plot is again, we have seen the box plot and that we draw to see whether any outlier is there in the data or not. So you can click here and simultaneously you will see that box plot is also appearing. So this is maybe the box plot of systolic blood pressure. You can see there are two data points, this one and this one, which is outlier. Then again, you can go down and you can see the box plot of diastolic blood pressure. You can see that there is one value. So remember what we discussed, that from that whisker, that is the whisker, then the lowest and highest. If any value is below or above that, then we call it as an outlier. That means the 1.5 box length from the edge. And this edge was Q3 and this was Q1. And this thick line, it is the median. And this point, that is the 1.5 times plus 1.5 times interquartile range. So this Q3 plus 1.5 times interquartile range is your this value, and it is lying above that. That's why it is an outlier. Similarly, you can see the other outliers also. Here you can see this SpO2, and again you can come and see. So these are the box plot. Now you can see an option of violin plot also. Ideally, this violin plot is not used, but since this option is there, so I'll just click and then you can see how it appears. So it is a variant of box plot only. And along with that, if you click on the data, you can see that the individual data point that also appears inside. So this makes a little clumsier look of the graph, this box plot. So normally I have never seen anyone using this violin plot, but obviously this is also one way of representation. So again, I'm unchecking this. So we can go simply by the box plot. And for categorical data, you can use the bar plot. So bar we all know, so that's why I'm not checking, maybe. So if you are okay with these options in the descriptive statistics, then we can move to the breakout room. So before we go to the breakout room, if any other query or questions are there, I would love to answer those questions. So you can unmute and ask also if you don't want to type, or like you can talk directly. So let me check the chat box. So I cannot see any message. Could you please
Dr. Saurabh
explain?
here, ma'am.
Yes, Saurabh.
Just one query, like when I was trying to go for the computation of the symptom scores yesterday.
Okay.
So while giving the commands and selecting the various symptoms over there, sometimes automatically the symptoms were covered in the inverted commas and not all the symptoms. So when I tried to remove the inverted commas over there, it was saying this symptom is like, I mean, this formula is like coming as wrong formula over there. And automatically, if inverted commas are there, it is taking as and it's computing the overall score. So why
when
the
there is
inverted commas were?
when there is only one word or as a symptom, like,
Okay.
then
Okay.
it takes as an inverted comma. And maybe when there are some characters, like we can see this. So if you can share and if you can show me, it will be easy for me to. Can you share your screen now? Or
Just
maybe
1 minute, ma'am. I'll do.
Or maybe we can go to the breakout room and I'll come to
Sure,
your
ma'am.
respective breakout room,
That will
wherever
be
you
fine,
are,
ma'am.
and
Yes.
then maybe I can see, so that the other participants may carry on with their activities. And then
Yes,
maybe
ma'am.
I can
Yes.
show it to the large group also. So
Yes,
Dr.
ma'am.
Vasav, can you please open the breakout room?